All right, good morning. I'm planning on doing the LeetCode contest 296 from last Saturday. I'll do that virtually. All right, here we go. Time to shine. Here we go. Putting these guys up. Okay, the next game. Finish one in the process. In other case, a new zero index integer array, new nums, the length half. I mean, index I, assign the value this guy as the minimum, that guy and that guy. Every odd one is the minimum or maximum with that guy and that guy. Okay, replace that with that. Okie dokie. So basically, we will. Oops, hold on. There we go. All right, 8:46 a.m. to whatever, how many minutes for the implementation. Oops. I don't know. Game plan is basically to follow the problem statement instructions. We can do this iteratively or recursively. Okay, let's do this. Managers. I'm totally stoked to be back here. So how many times are we going to do this? What does this mean? Return the last number that remains in nums. Okay. Alrighty. So if a.size equals, let's do this. Actually, 10 equals size. If n is equal to 1, return a sub 0. Otherwise, we'll just follow the instructions here. Right. Boom. Okay, so for I 0 is less than n plus I vi b of size n divided by 2. And then we'll return n max gain b. And so b sub. So if I and 1, so if it's odd, otherwise if it's even. Odd is the maximum of a sub 2 times I, a sub 2 times I plus 1. Otherwise, b sub I equals the minimum. Let's do this. I modulus 2 equals 0. It's the minimum. Otherwise, it's the maximum. Yeah, let's just keep it like this. It's fine. B sub I is the maximum is odd, otherwise the minimum is even. Something like that, right? Okay, uh-oh. Semicolon. Oof. Okay, it does not like that. Let's see. I is less than n divided by 2, right? That makes sense, right? You can't go off the end. Okay, so that's 1, and the other one is 3. Okay, that looks good. So it is 8:50, about 4 minutes from implementation. Of a recursive algorithm which results in PC. Let's look at what this looks like iteratively, and then we'll do it in the other languages as well. Right, so Actually, recursive is kind of, it's nice, right? Recursive works, whatever. It's not perfect, but it's fine. It doesn't matter. Let's just post this and move on. A few solutions. Recursive, reduce A to B. Kotlin, JavaScript, Python 3, Rust. But by the way, I'm really excited to be back here coding. It's been a while. I've been on vacation, so it's super cool to be back here and jamming. All right, good warm up. Let's do this. Python. Let's see. N equals length of A if N is equal to 1, return A sub 0, otherwise B. And return self dot min max game B. Let's do this. B is an empty array, and then for I in range and divided by 2. If n and 1, then it's odd. So what you odd is the max, right? Max. B dot append the maximum of A sub I 2 times I. A sub 2 times I plus 1. And the minimum. No, N is not defined. I want upper and where? Oops. I is the index. Okay, that's good. Yay. Yes. Here. Right, let's do Kotlin whatever. N equals A dot size. If N is equal to 1, return A sub 0. Otherwise, E equals mutable list of return max game B dot 2 array. For I in 0 until n divided by 2. If I just 2 is equal to 1, it's odd. B dot add the minimum. Right. All right, it's odd. Odd's max, right? Odd's max. Even min, right? Max A 2 times I. A sub 2 times I plus 1. Otherwise, minimum. Uh-oh. What does it say in here? Unresolved reference. No. Oh. Math dot max. Math dot min. Looks good. All right. JavaScript. Equals A dot length. Equals 1. turn a sub 0. Let's let b equal to this guy. Turn next game to b. 4, let I equal 0. Is this n divided by 2? Modulus 1. Then b dot push at dot maximum. They said it was 2 times I. They said 2 times I plus 1. Device b dot push this guy and do the minimum of those. All right, it's good. Ah, yay. Okay, stick that there. Then rest. Okay. Use. Is it use or type? Does that work? I forget. Yeah. Let's just return 0. Does it compile? I think it's fine, right? It's a type. Yeah, okay, cool. All right. Let n equals a dot length. If n is equal to 1, turn a sub 0. Oh. Otherwise, let's root b. Vector. Turn. I wonder if I can stick a self in here or not. Self dot max game. Oops. Max game b. Or I in. Oops. In 0 until n divided by 2. b dot push. Oops. If I and 1 push the use the comparison min and the maximum of a sub 2 times I, a sub 2 times I plus 1. Otherwise, push the minimum. It's even index. Let's see what happens here. Okay, let's do this. I and 1 equals. Look at 2 arguments. Was supplied. I don't know if that works or not. Maybe I can't do this recursively in Rust. I don't know. This function doesn't have a so. I did add that. What the heck? Reference to self. Yeah, I don't know. Did anyone else solve this thing in Rust? Let's go take a look. Rust might be non-recursive. Let's see. It might only be iterative, right? Okay. Interesting. Okay, yeah, whatever. Do it iteratively then, right? So turn b sub 0. And for this thing for now. Okay. Well, the length of A exceeds. All right, hold on, let's do this. mute in will a.length will reduce in while n exceeds 1. And we'll update it, right? So for I n 0 until n 2. Let's make it a lowercase n, whatever. Doesn't matter, I guess. And divided by equals 2. Right, shift it by 1. Sub I a sub I is equal to the maximum of a sub 2 times I and a sub 2 times I plus 1. Minus the minimum of those two. Okay. This. Is mutable. Start borrowing here. Expected mutable reference. Construct. Oh, do I need to put mute here? Yeah. Is it here? Oh, I see. Does that work? Mute? Just not mutable reference, just mutable? Okay. That verse is weird. Okie dokie. Good enough, whatever. Let's move on. Perfect. Okay. Recursively reduce A to B. Right. Okay, whatever. It's fine. Okay. First question took 18 minutes, 1 hour, 12 minutes left for the second question. 1 hour, 12 minutes remaining in the contest. Okay, here we go. 903. Integers. Okay, what do we got here? Can enter nums, enter k, partition nums into one or more subsequences such that each element in nums appears exactly one of the subsequences. Partition minimum number of subsequences. Such that the difference between minimum and maximum values in these subsequences is most k. Subsequences of sequence are derived from another sequence by deleting some new elements without changing the order of the remaining elements. Precision nums into 2 subsequences 3, 1, 2, and 6, 5. The difference between the maximum and minimum value in the second subsequence is that return 2 subsequences are needed. Okay, I think we can sort it and do a linear scan. Sort the unique values and perform a linear scan. All right, game plan. Sort unique values and form a linear scan via a sliding window. I think that works, right? So we can slide the window. We'll give it a shot, see what happens. Okay, so 5 a.m., about 2 minutes for the game plan. Okay, and then 9:05, whatever. That's for validation. Okay, here we go. All right, search. Oops. Okay, so sort A and then do a linear scan, right? So in, let's see, just size equals 0, j equals 0, while j is also n. Shall we go here? Trying to count to the end. Okay, so always add j onto the window. And so we need a high and a low. Start off with that. While the difference between those is less than or equal to k, then we can continue sliding the window. Okay, so increase the window size by 1 and then fix violations next. Low equals minimum of low a sub j. Similarly, high is the maximum of high sub j. If the difference between high and low exceeds k, and as low exceeds k, then we have to shrink the window. Right? Let's see. So hold on, let me look at this. Guys, example 1 equals 1, 2, 3, 5, 6, 2, 3, 4, 5. Nice, n equals 5. I and j are here. Low equals 1, high equals 1. Okay, move this forward. So low is 1 and high is 2. So that's fine. Increment the count every time we go through this, right? So, no, increment the count. On. Low, high, high. Once high exceeds that, then we have to break off that window. Okay, so if I'm going to break in the other case, right, and not increment the count if it's fine. Oh, I changed this in G plus 1. Oops. We can increment the window. Increment the window while we can. G plus 1 is less than n. And I minus low is this. Okay. Slide the window while we can, and then we can no longer slide the window. That's when we fix it and increment the count. Okay, so while low's on the left, high is on the right. Lows on the left, highs on the right. So you can use a sub J and then say sub I. Simplify this. While we can expand the window, right? So a sub 0, oops, equals 1, a sub 1 equals 2. So 2 minus 1 is less than k, right? K equals 3, 2. K equals 2, equals 5. Less than is less than or equal to k, so we commit j. A sub 2 is equal to 3, that's fine. We commit j. 6. A sub 3 is 5, and that's a violation. Right, so that's when we have to move I to j. It's j. Wait, hold on. Yeah, equals j, and then increment the count. And this is going to collapse the window, right? So expand the window, collapse the window upon violation. Okay, something like that I think would work. Oops, hold on, no. When we cannot expand the window, hold on. Current is fine. And no, that's fine. That's okay. The current. Hold on, let's look through this again because I didn't quite do it right. Gotta go slow to go fast, right? So 1 I equals 0, j equals 0. Okay, that's fine. So j equals 1 is 2, right? J equals 2, which is 3. And when j equals 3, then there's a violation, right? So we can't increment anymore. The violation occurs when we should increment the count. Count initially starts off at 1. Now I do want to get to the end though, right? J is less than n. Maybe it doesn't get to the end there, right? J plus 1 is less than n. It doesn't end. Okay, that looks fine then, right? I was off by one. It was 2, 2, and 3. 2, 2, and 3. Okay, so that's cool. Right, nothing too fancy. It's good enough, right? Let's post it and move on. So I'll sort the input array A and use a sliding window on the array. Button, JavaScript 3, Rest. Oops. C++. All right. Hey, Sam, good morning.
Yeah.
I'm doing a LeetCode contest right now, partner.
After you're done with that, can we still be standing?
Ooh, yeah, that's a good idea.
Like sit
Yeah, I'm studying and working today though. Okay, partner. So I'll take a break. I'll take a break and do that. But hey, partner, that your door is locked. Okay, so I don't want you to come in. You know, I'm studying here. Okay, so please respect that, partner. Okay, I'm working really hard. Can you let me get back to working, please, without interrupting me? I'm trying to get 4 out of 4, Sen. I'm working really hard. I just got my second one, so I got 2 more to go.
2 more to go, and
yeah, okay. All right, I love you, Sen.
I mostly get B's and A's on my section.
That's good, Sen.
No F's.
I love you, partner. Okay, that's such good boys. All right, so what is this? It's inappropriate. Holy cow. Most unhelpful family ever. Holy cow. Okay, we're replacing these things with that. What is this? What? I'm trying to do. Would you quit syncing here? I thought I told you to forget this thing. All right. Reset, okay. Replace the 4 with the 7. Replace the 6 with the 1. They're all distinct, so we can use a map to store, right? All right. All numbers in the input array are unique. So we can use a map for 001 lookups for replacements. All right, there's the game plan, 9:27, 3 minutes. 9:27 a.m., about 3 minutes for the game plan. Okay. Come on, let's focus. Plenty of distractions in life. All right, here we go. Okay. App is unearned. App of integers to integers. Okay, for each integer index of A, I just need a size. Let's do this. And okay, so M sub A sub I equal to I, right? So given the value we're trying to place, there's the index of that value, and then return A at the end. After the modifications for op and ops. Pass by reference, it's integer. Previous and current value, all right, is tied to the operation. It's one. Okay, so I goes as previous value. Is that 37? Okay, and 2 1 for the other one. It's good. Oh, what is this? What? Holy cow! This thing's huge. Oh, mine's answer's way off. Okay, let's see. 9:27, 9:30, 3 minutes. Rotation. Rotation. So let's see. Answer. Okay, so what did I do wrong? Let's see, maybe I didn't read it right. They're all distinct. You apply M operations. All right, whatever. The ith operation play the number. This guy with that guy. This exists in nums, but that does not exist in nums. One with the 3. 4 with the 7. 6 with the 1. Will not exist when implying that. Into the 6th. What the hell? What's wrong with this? It's 92. Let's take a look. The input. Holy cow, this thing's huge. Ugh. Come on, this is stupid. What is 92? 92. You see 92 with 93. How? Why are these things redundant? One should be replaced with 92. So what the hell? 192? Does this exist? How's it? And 91 is replaced with 92. Output is 1. I would expect 92. Hold on. What is the 1 replaced with, right? It should be 1 is replaced with what? One is replaced with 2. Are we doing these replacements over and over again? To read the problem statement again. Let's this is something. Ith operation, you replace the number this with that. In the ith operation, this exists, but that does not exist. The operation is I see. Okay, so I can't do it this way. It's fundamentally incorrect. It's like dominoes. Okay, so the input is structured in a way where the result is dominant. And so this goes to that, goes to this, goes to that eventually. So we replace it and then fine, so we need a linear. Let's turn into that. Okay, so as we update the array, we also have to update the map. Right, so update the map. So per was I. Is that good? 3271 1 2 1 2 1. Okay, but then this one is it okay like that? Just update the map as we go. Okay. Yay. Okay, so fix I update the mapped indices as we go. Okay. 937, 932, 937, about 7 minutes to analyze gigantic input array and find out that I solved the problem. The domino effect is taken into account when we update the map during the linear scan operations. Okay, right, that's fine, whatever, let's move on. Right, here's this and get going. It'd be awesome to get to the 4th question and answer that. All right, so a few solutions. Use a map and to store the index I of each value of the input array. Okay. Outline, JavaScript. 3. Oops. Rust. Okay. 3. Oops. Turn in the end. Oops. And we close a dictionary. I X for I X and enumerate A. All right, that's the index and value. And then for recur and ops, M sub pre equals cur. We say I equals M sub pre, so A sub I equals cur, M sub cur I. Something like that. Oh, I equals M sub pre. I think that's right. Hold on. That looked okay. This will not be right here for previous. What? Okay, hold on. Let's do something wrong. Let's print the map. Okay. Oh, it's backwards. Okay. X exists at index I. Right, yeah, makes more sense. Here we go. Okay. Oops. It should be fine, right? Whatever. Just run it, see what happens. It's okay. Yay. It's okay. Boom. Right. JavaScript. Array and operations. After all those operations. And will be our map. Oops, new map. Okay, so for zoom, I'll just say link set ACI I, and then we'll let previous and current values of the operations. M dot set. Let's see what I equal M dot get previous. A sub I is current. M dot set current to I. Go. Looks good. Okie dokie. Holy cow, my kids could not be more loud. That's good practice. Good practice, trying to think. Extremely loud environment. Okay. Name is a readable map. Integers, integers. For I in 0 until equal size. So A sub I equals I. For previous and current values of the operations. In the end, I equals m sub previous, a sub I equals current, m sub current equals I. Already big money, no whammies. Kotlin. Okay, Rust last. Save the best for last, right? Here we go. Use the collections hash map. Type AI goes back to goes back. Clean this up a little bit. API, oops, API, turn integers at the end. It's got to be mutable. And equals hash map. Hash map, and then for I n 0 until a length. And insert piece of I for previous current bias in the operations. I equal him dot get previous dot unwrap for one is nah, whatever, zeros. Right, I think it works. Okay, then a sub I equals current and dot set I, something like that. Oh, option. Okay. Let previous current go on unwrap. Oh, op sub 0, 1, right? I want to destructure that vector. Previous expected that, I could borrow it, borrow that. This guy, borrow that guy. Borrow the 0. It's I32, so it needs to be a U size, right? It's U size. U size. It is U size, isn't it? I thought. Oh. Oh. Set. Oh, inch. Insert our update. Hold on, I have to look this up. Rust. Where's, hold on, I think I have it bookmarked, right? Oh, where's the, let's do this rush hash map. I'll look at the documentation for this thing, right? We want to insert the value into this thing, right? Okay. Choose insert then. Oops, hold on. Insert. This guy. Guess that is that. Index by U size. What is I? I is, I don't know, is the U size. I don't know if I can do this. Clone this thing. And it's moved. Does that work? I don't know. I'm not clone, it'd be a copy. The heck? Expected use size found a reference to use size. Optional location of that thing. Does that work? Reference. Oh, can I just do reference that thing? Okay, looks good. Big money, no whammies. Yay. Okay. Looks good. Use map M to store the index I of each value and put array A. Whatever. Good enough. Right, it's cool. Okay. So it had to be perfect. 24 minutes left in the contest. This is cool. Chance of getting all four here. 24 minutes, right? 0 hours, 24 minutes remaining. Contest. All right, it's 9:51. Okay, hour minutes for game plan. Here we go. Another game plan. Assign text editor with the cursor, following, add text where the cursor is, delete text where the cursor is, simulate a backspace key, move cursor to left or right. When deleting text, only characters to left or right. Left of the cursor deleted. Okay, the cursor also remained the actual text, not be moved beyond it. More formally have, right? Okay, that makes sense. It's text to where the cursor is. The cursor ends to the right of text. Delete text. Text out length K is 40. 20,000. So offhand, I'm thinking it'll be just a doubly linked list, right? Characters, right? This is the underlying data structure. Right. So we can insert in the middle. Okay, so 9:53, 3 minutes for game plan, 9:03 a.m. to 100 minutes for implementation. Let's get going. So list goes list characters. Don't need that, right? The constructor. Current index. Where does the current index start? 0 is where it would start, I suppose. Add text, it goes to the end of the added text. Delete text returns 4. Current text is delete. If you delete 4 characters. Practice. Cursor right 3. The cursor cannot move beyond the actual text. You notice did not move. Last 10 characters to the left of the cursor. So the index I be our cursor. Just 0 is fine, or whatever. We can do this text editor. A is fine, just I needs to be initialized to 0. Now, whatever, we can explicitly do that. 1 second, go P. All right. How much time do we have left? We have 18 minutes. Okay. So constructor and text. Okay, where we're currently at. So C++. Oh, what am I doing? Hold on. Let's go to this guy. All right, I want to look at a list. Where is list? Insert, I think is what it is, right? Insert. Position by, yeah, that works, right? For auto character and string. For each character in the string, insert. All right, position value. Position value. Delete text left of the cursor. K equals minimum. I mean, you can delete itself and I. Erase, I think. Erase. Erase in position I. Okay. Delete to the left. Okay, minus a dot erase. Okay. And then delete text with return integer. Text from where the cursor is, simulate the backspace, delete text, because that's where it is currently. It's I, and I'm going to delete K from it. Delete text at I. Inclusive. Turn I. Let's test it out for sure. Cursor left. Because minimum K and I. Cursor, wait, hold on. Maximum of bottom out at 0. I minus K. Cursor left. Last 10. Cursor to 10. Turn the string of that. Cursor right. 10 characters to the left. Oh, it's left of cursor left. Move I there. And then return the left 10 of that. I left and 10 after that. Yes. Left 8. All right, so we were before we were here, right? All right, so cursor I was 12. And move it 8 over, so it's gonna be right. So it's 12 minus 8 is 4. And the cursor was there. Now the cursor is here. After that. Eight up again, plus I. Then we want to do 4. To the left. Again. Plus maximum bottom out at 0. I minus 10. All right, 10 previous to that. Okay, so cursor right, I equals a minimum of I plus K and that size. Cursor right will return the last 10 as well. Okay, let's see what happens. Uh-oh. No matching function call to insert constant iterator position. Okay, so insert a dot begin plus what? Distance. Wait. Iterators. I haven't used double linked list in a while, so it's iterator position, not index position. Iterator. List iterator, yeah, it could be. Using bitter list iterator. A dot end. Does that work? I think so. Let's do this, return 0. See if that'll compile even right. Try empty string. Try empty string. Compile, yeah, okay. Okie dokie. Distance dot begin. Editor. The distance from A dot begin to the creator. Distance that minus K. Is where it goes. Backwards. Ten to the left of it. And left. 10 to the left of the iterator. Left will be maximum of 0 and the distance again to it. 10 distance is an integer. R equals the minimum of again. It's plus and moving the cursor to the left. So the index I will go as leftmost as possible as it can until it bumps up to 0. Move the iterator back. Left, bottom out at 0, go to the left by that much. Right. to the iterator itself, right? Begin until the iterator, right? Begin plus that. Okay, so and to the iterator. I get all right. I equals the minimum of distance to begin it plus k size integer. Move the cursor to the right that much. While I minus plus it. So the begin is the beginning of A. It should be the same thing, right? Same exact thing. Trying to begin. Something like that. Okay. Whoa. K in distance. Okay, so K in distance. Integer. Zero distance integer. Going to U size. Distance. Whoa. Beginning is. Dang. Okay. Beginning to it. All right, we'll just take it, right? Take string to return. Beginning until it's take does not equal it. S dot push back object in the location of take and then move take. Same for this, right? It's just the same exact thing. Something like that. Whoa. Can't, okay, I can't go like that. All right. Okay, so all right. Okay, so obviously I have some room for significant, right? Significant room for improvement with doubly linked once to the plus. I haven't but the gist of it is that I cannot skip past indices. The iterator moves one at a time. Oh, well, the contest ended. Okay. All right. Well, okay. And I ran out of time. So add this to the upsell bucket. Right. Catch you next time. Cheers. Beer.